Hey guys, my name's Alex Baransky. I'm a Python instructor. Let me just get some stuff set up here. I hope everyone's doing well. Today we're going to go over an intro to web scraping course. This is going to be a much more abridged version of the of what you'll learn in the bootcamp, but we're hoping just to give you an idea of our teaching style and what we have to offer at the bootcamp, and kind of just a demo lesson to see if our teaching style is compatible with your learning style. We hope it is. I really like teaching, and I hope you guys enjoy. So let me go ahead and share my screen here. First thing we're going to do here is we're going to open up an Anaconda prompt, or if you are on Mac, you're going to open up a terminal, and you're going to go ahead and go into your terminal or Anaconda prompt and type in Jupyter Notebook. And this will open up the Jupyter Notebook that we'll be working with. And as Drace mentioned in the chat box, if you haven't downloaded the notebook yet, I encourage you to, so you can follow along during the lecture. It should be there under syllabus, and there's a file called Introduction to Web Scraping. So once you type this in, you can go ahead and click enter. Yeah, so Anaconda is kind of the framework, or the package that you can install, which includes Python 3, which is what we use in the bootcamp. So for those of you who have worked with Python 2 before, maybe we work with Python 3 in the bootcamp, which can be installed directly by installing Anaconda. So once if you download that, it should be in your downloads folder. You can see this little navigator page here. So we can go and click on Introduction to Web Scraping. It should open up a new window here with our wonderful lecture. So let's talk about web scraping and why we're here learning it today. Clearly, you guys are interested in data science. Otherwise, if otherwise you wouldn't be here. So data science is really awesome because we're able to take data and extract benefit from it, right? So a lot of people look at a spreadsheet or look at a bunch of numbers and they see gobbledygook. But the beauty of a data scientist is that you're able to take this information and convert it into something that a business can use to make money, or to be more prosperous and to advance and grow. And that's really what I believe a data scientist's real role is to help companies find the value in the data they have, and to communicate that value to the people in the company that make the decisions, so that they can help to make their company grow. So what about web scraping? So web scraping doesn't really have much to do with data science. It's more of just a tool you can use to do more data science. So what you can do with web scraping is, for example, let's say, well, let me just say just flat out that data is expensive. Generally, solid data is very expensive. And there are many companies out there, like Nielsen, for example, who sell data to companies, and they charge an exorbitant amount of money, millions of dollars generally, depending on what you're looking for. But web scraping is a great way to automate a process to extract data from the internet that is publicly available. So for example, let's say maybe Best Buy wants to know what competitors' customers are saying about their products, or maybe their customer service. You can write a web scraping script to scrape other competitors' products and see what the reviews are saying, see what the general rating is, see if there are some common terms that are used in good ratings and some common terms that are used in bad ratings. We could use something called NLP, or natural language processing, to do that. And we can extract that data for free, and for something that would cost a lot less than maybe buying that information from your competitor, if it's even available. Generally, competitors are not going to give you that information. So web scraping is definitely a relevant skill, although you may not be directly interviewed on it. It's definitely good to have, and not only that, but it's really good to create your own data sets so that you can do data analysis on them and look into kind of interesting topics that maybe haven't been looked at before, or if they have, very seldom, because the data is just not easily available. So generally we use we use web scraping to scrape sites like IMDb is a popular one. We're going to scrape Yelp today. But generally, you don't really want to scrape sites where the data is available for download in a CSV file or an Excel spreadsheet. For example, lots of government websites will have the public data available to download as some sort of spreadsheet. Generally, you don't really want to scrape those kind of sites because there's no real value in it. But things like scraping reviews from like a Best Buy or like Amazon, or you could even scrape things on Instagram or Twitter or things like that. It becomes more complicated, but there are ways to do that to kind of do some investigation there. So let's jump right into it. What is web scraping? So web scraping, like I kind of gave you more of a general description of it. It's really just taking information that's publicly available on the web and making a script to automatically scrape that data and put it into some sort of easily usable format so that you can do data analysis on it, or whatever you want to do with it. So first we need to talk about HTML, which I'm sure everyone here has heard of, but it's short for Hypertext Markup Language. It's essentially the language that is used to display a website. So if we go to Google, for example, this will show the HTML here, or the graphical representation of that code. Now going forward, HTML is just plain text like any other coding language, and it's just interpreted by your browser in certain ways. For example, this Jupyter Notebook is written in HTML. You can't really see it because it's being interpreted by the browser and printed out very nicely. But behind this, you can see actually, this is all the HTML on this page, and you can see all the different elements, and we're going to get into this tool a little bit later. So plain text is turned into an HTML document by using tags that are then interpreted by a browser. So we're going to get into tags. We're going to get into the anatomy of an HTML document in a minute. There's a module called Beautiful Soup. I believe it's actually a class that you could use to easily extract the tag values from HTML source code. And this is kind of how we extract data. Just because data is on a page, I'll say it doesn't mean that it definitely is organized, but it's not organized in a way that you can click a download button and download the data. But it is organized in a way that humans can separate the data by different rows, or maybe like little advertisements in between. So the data on a website is going to be organized in some way, and we count on that to use the tag values to extract the information and then write it to a CSV file. Generally, is what we're going to write it to. So let's go into an example HTML document. So here we have this this code here, and if you look at this, we have these are the tags here. So this is a tag. This is the close tag. So every tag has an open tag and then a close tag, and you can tell the difference because the close tag will have this / here, and they will have the same contents. So here we have this HTML tag, and then inside we have a head tag and a body tag. We have a title tag, and inside the body tag we have an A tag. So you can see there is this sort of nested structure here, and that's what we use to kind of show an address or a directory for these different tags. And I'll make that analogy again in a couple minutes. So here we have the title tags in this example designated which designates the enclosed text as the title to be displayed in the head of a browser tab. So for example, this HTML code here, if it were to be interpreted by a browser, up here the title tag would show the text to be shown here. So for example, the value of this title tag in this document is Introduction to Web Scraping. Tags are always enclosed by these little less than greater than to distinguish them from the content. And a pair of tags consists of start and end tags, which carry the same name, but the end tag is preceded by this /. So now we're going to get into values. So we have kind of a name of the tag that's kind of like maybe like the address, right? And then each address will have a value. In this case, the value of the title tag is this hi string here. Okay, so the value of this tag is hi. And that is just the text that's kind of enclosed within the tag. Now, if you can see down here, this one's a little bit more confusing. This is an A tag, and we're going to get into that in a second. but you can see that the value to this A tag is hello beautiful soup. It's the string that is located in between the open and close tag. Okay. So going forward, tags also have another feature called attributes. An attribute is, in this case, kind of an identifier for the tag, right? So you may have multiple A tags in a document, but every A tag is not necessarily going to have an href attribute equal to this link here. So an A tag stands for anchor tag, and anchor tags will always have this href, which stands for a hyperlink reference. And if you know about hyperlink references, they're just these links here. So this A tag actually brings us to this beautiful soup page here, which we can go here and we can check out the documentation and where you can download it and things. But it makes what you would assume a hyperlink or a link to tech, a link to a website, and you can change like a word like "hello beautiful soup." In this case, will now be the link to this this URL. So we went over a few things here. So we have the tag, which are these kind of general little identifiers. Then within the tags, we have these values, which is just the string from with it that's enclosed in the tag. And then you can also see the attributes, which are enclosed in the tag. I'll rephrase that. The value is enclosed between the open and closed tag, and the attributes are enclosed within the open tag, right? So you can see the difference here where hi is located between these open and closed tags, and then we have hello beautiful soup is enclosed between these open and closed A tags, which is the value of this A tag, but the attribute href is equal to this link here. Okay. So let's talk about beautiful soup. So beautiful soup is a class that we're going to use to make an object, and all it is essentially is it uses HTML parsing, and it parses through text to find these tags and kind of store them and make them easily accessible, and the values within them easily accessible. So if you think about the source code, like I was talking about before, HTML source code is just it's just a string. It's just a bunch of text, right? So we're going to need something that can go through this text and say, all right, here's the HTML tag. Within it is contained a head tag and a body tag. Within the head tag is a title tag with the value hi. Within the body tag is an A tag with the value hello beautiful soup and an attribute href equal to this link here. So there's a bunch of different information. There's a bunch of information here, and beautiful soup allows us to access it very easily, which is going to be useful later when we want to access other things on different pages and extract that and then save it into a CSV file. So if you have Anaconda installed, you should have this BS4 package or module installed. But if you don't, you might want to go ahead and install this at a later time or do it now. You can just do pip install BS4 within the Jupyter notebook. This should run. So I'll leave that there for now. So that will install this package. So we want to import this beautiful soup class from within this module. And what we're going to do is we define this string called HTML string. And if you don't know this triple quotation syntax, this is just called a long string, which allows us to click enter here. Whoops, not 32. Enter, and then this string will actually will keep track of this new line character. So instead of writing a whole long line with separated by new line characters like this, right? And then a tab here, and then a new line character, or actually the other way, right? So instead of doing all that, we can just type it in as we want to see it, and then this triple quote enclosing it will keep track of all those new lines and tab characters. So when we create a beautiful soup object, we're going to have to call the beautiful soup constructor, which is what this is here, and then we pass two arguments. The first argument is the HTML string, and the second argument is going to be what type of parser we want to use. So in this case, we're dealing with HTML source code, so we want the HTML parser. There's also XML parser and different other kinds of parsers, but XML and HTML those are the two most popular parsers. But today we're going to be using HTML parser because that's the type of source code we have. So I just want to walk through this before we run it. So we create this beautiful soup object. Then we're going to go ahead and print the type of this object. then we're going to print a new line, and then we're going to actually call this method called Pretify. So if we go ahead and run this, we can see here this is the output from the print type hi, and we can see this hi object is now class beautiful soup, bs4.beautiful soup. So that's the type of object we have. And then this hi.Pretify is actually taking this code and taking this object and then printing out the text in a nicely formatted way. So we can see here that the hi tag, the hi value is enclosed between the title tag, the hello beautiful soup is enclosed between the a tag. It's just a nice way of printing this out in a kind of tree or formatted structure so that it's not all just jumbled and we can kind of look at it. Now, most pages we look at are going to be way too long for this to be relevant. So I mean, you can see even this simple Jupyter notebook has quite a bit of HTML code. So using this Pretify on this is probably not going to be too useful, but just to know that it exists, so you can print out these simpler HTML source codes. So this is just the way to do it. Okay, so now we have this hi object instantiated, and we're going to go into some of the operations we can do. So Beautiful Soup can extract the name, value, and attributes of tags, right? So let's just go over that again quickly. So the name of a tag is just this here. So the name of this tag is HTML. The name of this tag is body. The value of an attribute is what the string that's enclosed between the tags. So the value of this title tag is hi. And then the attributes of a tag are these here in the opening tag. So for example, this anchor tag, this a tag, has an attribute href, and that href value is this link here. So in order to extract these different attributes, I don't want to use the word attributes, these different things that belong to this beautiful soup object, we have these different methods here called name, string, and attributes. And if you can imagine, name gives us the name, string gives us the value, and attributes will give us the attributes. So if we look at hi, and I'm just going to say this here, and by the way, I'm going to be doing a lot of little shortcuts and stuff, but I'll just try to mention them while I do it. So if you click on a cell like this and then it's blue, if you click B, if you press B, it will insert a new cell below. And then if you want to run a cell, then you just do this, and then you can do Shift Enter, which will run the cell and go to the next cell, or Control Enter, which will run the cell and stay on the same cell. So, and then here, if I click this and I click X, it will cut the cell, and then V will paste it again. So, these aren't really necessary to know, but definitely to run the cell is important. But you could also click this. But these are little tips that make it easier to code and things like that. So you'll get used to them over time. So here we have this hi object, which is what I wanted to show. And if we're going to look at this hi object and try to get the a tag. And if we look here, if we do .a, this will extract the a tag from within this hi object. Okay. Now, if after that we do .name, we should see that we get a. We get the string a. That's the name of this tag. It's the a tag, right? If we want to look at the value of this a tag, we type .string, and that will return the value. So I'll do hi.a again, so we see this here. So we see hi.a.string. Here's our hi.a, and then our value, or the string, is this here. So we get hello beautiful soup. If we want to look at the attributes, we do hi.a.attrs, and as you can imagine, you can have more than one attribute per a tag. So href is one for a tag, but another popular attribute is class. ID is another popular attribute. So there's many different attributes, and a tag can have many different attributes to identify it or to make it unique from other tags. And we'll use this to kind of identify different elements on a page that we want to extract. So here we can see that this attributes method, what it returns is this dictionary, and this dictionary happens to have one key and one value for that key, and that is and I just want to show you that it is a dictionary, and that key is the name of the name of the attribute, and the value is the value of the attribute, right? So this is a nice way we can extract for example, what this link goes to, right? So what does this text bring us to? Well, we can say, all right, I want the attributes of the A tag from within the hi document or the hi object, and that will give us this, and then we can go in there and extract that key, and now we have the link to that website, that URL. This is just a nice way of printing it out here. Okay. So going forward, we have some other methods here. Now, if I print out hi here, and you can see without the Pretify, without the Pretify, you can see that it's not formatted very nicely. And neither is this. I think I have to print it because it's separated by new line characters. So there's the Pretify. So if I print hi here instead, you can see it's not as nicely formatted, so it's harder to see the structure, the hierarchy of the tags. So let's say we want to extract all the values from within the HTML tag. Well, I want you guys to look at this and think about, does this HTML tag have any values? Yeah, so back here when I did this, this attributes method returns a dictionary. So from here, we can just say href because that is one of the keys in this dictionary, and that will return that. So here, if we try to do this print hi.html.string, we see that we get a none object. We get a none return here. And that's because this HTML tag has no value in between it. There's no text wrapped in between here. It's only other tags. So these other tags kind of hide the values of their own tags, all these child tags as we call them. So the HTML is the parent tag, and then head is a child tag, and then title is a child tag of the head tag. So it's kind of like this tree structure. This hi and this hello beautiful soup are kind of hidden from the HTML tag, so this will not work. So what we use instead is something called a method called getText. So this getText method will extract all the text, all the values from within all the child tags of this tag. So that means that it extracts all the values from the head tag, which there are none. It extracts all the values from the hi tag, from the title tag, which is hi. It extracts all the values from within the body tag, which are none, and then it extracts all the values from within the A tag, which is this hello beautiful soup. Okay, so this is a nice way to get all that nested, all those nested values that are almost hidden by using simply the string. So going back to what we did before with our dictionary with the attributes here, like this is one way to extract the value of an attribute. But another way is actually to use this get method, which is used to find the attribute of a tag. So for example, we can get the href of an A tag using the following code. It is the same as running this and then finding the value of the key from the dictionary, right? So if we print this, you can see here that this .get will know that we're looking for the attributes and we're trying to get the href attribute from this A tag, okay? And this will show you again the dictionary here, okay? All right, so now we've got some basic stuff under our belt. We have a few other two methods that we're going to do, and then we're going to look at some examples, or one example. Okay. Why do we need to write hi.html? Well, the hi.html, if we do hi.getText, this will return the text from within the entire HTML document, but generally that's not what you want. So what I wanted to show was that, for example, we want all the text from within the body tag, right? Or we want all the text from within the head tag. Generally, you're not going to just want to say the entire document, give me all the text, because it's very, the formatting will be very off and it'll be all, jumbled up. So generally, you want to only get text from within certain certain tags within the document, but let's say that you don't want to have to specify every child tag of the head tag, and then have to say, head.a.string, and then maybe there's a hi.head.div.string. Like these are all different types of tags here. A div, there's hi.head .li.string, right? So otherwise we'd have to list every tag that is underneath this head tag. But if we just do .getText, that will give us all the text if we know that that is what we want from within. If we know that we want all the text from within that tag, right? Good question. All right, so find and find all. So these are for finding tags within the document. So before we had a much simpler source code here. We have a much simpler source code, and it's very easy to kind of go, and we can just say hi.a here, and because there's only one a tag within the source code, it will know to go straight there. But let's say that we have hundreds of a tags within our web page or our source code. It can become much more difficult to find the things we're looking for. So that's why we have these find and find all methods. So here we have a more complicated some more complicated source code here, and we're going to create a new beautiful soup object called article, and we're going to pass in this article HTML string, this long string, and then of course the HTML parser that we're going to use to parse this source code. So let's say, let's kind of take a look at this this article object real quick, and let's say we want to print this. We want to print the prettified version. Also, something really nice to note, if you're using an IDE like this and you've already created this variable, if we start typing and then type tab, it will autocomplete it for you, which becomes very nice. But I would recommend when you're first learning not to use that, because otherwise you start forgetting the names of certain methods. So it's good to get the muscle memory. But after a few months or even years of working, it becomes very very, yeah, Trace is guilty. I'm guilty too, but it becomes, it makes your workflow much easier. So, so we can write this article.prettify here, and it will print this out, and we can see the structure of this HTML document, or this HTML source code. So we can see here, it looks like, we have this open HTML tag, which signifies that the document is HTML. We have a head tag here, which is closed down here. And within that head tag, we have the title tag, and then the article is the value of the title tag. Then we have our body tag, which is this value here. And this is what is contained within the body tag. And within the body tag, we have a header, we have a paragraph, we have a second header, we have a second paragraph, we have a third header, and a third paragraph. Just so you guys know here, these header tags, H1 is the largest. I can actually show you in here. So we can actually change our cell type to markdown by if you click on it and press M when it's in this command mode instead of input mode. That's when it's blue. Or you can just go up here and you can change it from code to markdown. So if we do $ and then words, oh, there must be a space here. It will show this nice header here for us, big text. And then if we put 2, it'll make it smaller. And you can see as I add more hash symbols here, we will get smaller and smaller headers. So hash or H1 is the largest. So H1 meaning 1. That's the very largest. And then as you add them, it's H2, H3, H4, H5, H6. Okay. All right, so we've got a bunch of H1 header tags. We've got a bunch of P tags, which stand for paragraph, and then within some of the P tags, we have some other tags. So we get a nice little overview of it here. Is there a way to get all the tags available in an article printed out in dictionary form, so key value pairs wherever there's a value and empty string if no text? Interesting question. I don't know if there's a method offhand that breaks it down like that. You could definitely write a recursive function that would go through and maybe make a dictionary for you, like a nested dictionary. But we're gonna show ways of kind of, you generally don't want the entire document broken down for you in terms of which tag has which value, because it would just be madness. And there are many different tags that have the same name, but the tags happen to have different attributes which identify them. So if we just had a dictionary where the keys were were the tag names, there would only be, maybe, I don't know, 25 or 30 different tags in a document, but there'd be many different attributes that distinguish those tags that are used many times over, that would confuse the dictionary, and the dictionary entries would be overwritten. Okay. Okay, so if we want to get the p tag from this article object, this beautiful soup object, we can write .p, and we can see here that it only returns the first p tag, and then we can see here this is the first paragraph, right? So we can see here we have this paragraph, we have a second paragraph here, and we have a third paragraph here, but we're only getting back the first. So if we use this .find method and we put what tag we want inside the find method as a string, that will give us actually the same exact thing, which is what's going on here. If we want all the p tags, what we do is we do find all, and that will go through the document and find all the p tags and store them in this thing that looks like a list. I would like to show you what this object actually is. So I should probably have this here. So if you're familiar with Python data structures, this looks like a list, but it in fact is not a list. This is a different type of object. This is called a result set. So we have here a result set that contains the results from our operation. Now within this result set, each element kind of looks like a string, but it's not enclosed in parentheses. So that's something that's important to distinguish, is that within this result set we have these elements here, but they are not strings. So for example, if I now say article.findAll p, and then I take the first element from within here and I look at the type, we actually have a tag object. So what I'm trying to point out here is that we can actually from here go and say string, right? So we can extract the element from this result set or list-like thing, and we can get the first element from there, and then we can call this string method on it in order to extract the string. So these are absolutely still workable, where we can go through these tags and maybe iterate over this list or this result set and do some things to extract the information from these tags, which is exactly what we're going to end up doing. So I just wanted to point that out there. So we've got our p tags now, and now here we want to find tags that have specific attributes. So you could actually pass a dictionary as the attributes argument. Okay. So what we have here is we have a find all, and we want to look for h1 tags where the attribute ID is equal to 1. So the ID attribute is a special type of attribute with HTML because it should be the value should be unique on the page. So for example, you will only have one tag on the page that has an ID equal to 1 if it exists. You will never have more than one. That's just kind of how it's made. So ID is really supposed to be unique. So if we print this, we'll see that we actually do get back this this h1 tag, and the ID is equal to 1. So this is nice for if we want to look for certain things, and I'll show you some examples. For example, class is a very big one. Class equal to some value that distinguishes the class, and that will extract a whole bunch of different elements that we can then use to extract text from, or just like we did up here, where we'll iterate through it and then extract the text and save it somewhere. I also want to point out that you can actually pass a lambda expression here, or a function. So let's see if I remember how to do this. Lambda x.name, or I'm sorry, x.attributes, or let's do ID in. So we want all the tags that have ID as a key in the attribute. Okay. So here we have the h1 tag, the h tag. All of these have ID attributes. They're different ID attributes, but we have now extracted all of the tags that contain or that have an attribute that is ID, an ID attribute, right? Regardless of what the value is. So this can be very useful if we're looking for certain tags that you could put whatever type of function here. If you guys are familiar with filter expressions, so this filter function, which is really useful, we'll cover it in the bootcamp. But this filter takes an expression called, or a function called a Boolean function, and the Boolean function will return true or false based on what's passed to it. And if it's true, it will keep it. If it's false, it'll get removed. Can you filter the attributes with specific values? Of course you can. So for example, X attributes ID is equal to 2. Let's see what I got. I'm gonna have to do a get here so we don't get an error. So there we go. So if we put the attributes like this, and we put this in here like a dictionary key like I did earlier, the problem with that is that we're going through a whole bunch of tags, and if we run into a tag that doesn't have the ID attribute, this will throw an error when it tries to check it. However, the get method will return a none instead of throwing an error, which is a nice benefit of this .get. Okay, so this will give us the tags that have ID equal to 2, which should only be one tag on the page, which happens to be this h2 tag. So this is a very basic introduction to Beautiful Soup, and we have some tools under our belt now, and we're going to go and try an example in 10 minutes. So what I'm going to do here is we're going to look at this Yelp page. Yelp is a really nice page to scrape if you want some practice. There's a lot of good information here. There's kind of the name. There's how many reviews. The food types. How many dollar signs. There's like the hours. All this good stuff. And then there's also reviews, which is what we're going to end up scraping here. So this is a great site to start scraping. It's pretty simple. The site, it's pretty static, so you don't have to worry about like ads popping up and things like that. So what we're going to do here is we're going to scrape the URL, the reviews for this restaurant called ABC Kitchen. So we see here we have like a username, we have a location, we have the date posted, we have how many stars, the content of the content of the review. So there's a lot of good information here. Now we could also see down here, if we go all the way to the bottom, that there are multiple pages here. There's 143 pages of reviews, and we want to get more than just the first page of reviews. So what we can do is, and I encourage you to do this on every page to see if you can even scrape the page, is we're going to open up a text editor, and paste the first page URL here. Okay. This text editor is called Sublime. It's a free editor, and it's really nice for working with if either you're running Python scripts or working on projects, or it's really nice to use. So we use it in the bootcamp, so I would recommend downloading this if you need an editor. But you can use like Notepad or whatever for right now. It's not a big deal. If we click next, what we're looking for is a pattern in the URL. And I'll explain why in a minute. So we'll put this here, and we go down here. Next, let's copy this and put it here. And hopefully you're starting to see this pattern that's developing that we're going to need to use so that we can navigate from page to page. So here we can see that on the first page there's nothing kind of appended to the end here, but then every other page after that has a question mark start equals to some number. So it looks like every page has 20 reviews, and it's telling you what number of review you want to start at, right? So we want to start at review 20, we want to start at review 40, and so on. So this is nice because this means that we can actually navigate to different pages. The reason we can navigate to different pages here is because we're going to need to create these response objects from the request package. So the request package is something that we use to send a request to a server with the URL, and then get a response that contains the HTML source code. And then once we have the response object that contains the source code, we're going to then parse it and then create a beautiful soup object. So before, what we had is we just had these strings that we were using, that we were defining ourselves. But when you're actually scraping a website, you're going to need to get the source code from somewhere, and this is how we get it. So we import this request package, which is kind of the industry standard. It's really used for doing a whole bunch of different things. But what we want to do is we would do this request.get method, and then we pass the string of the URL that we want to get the response from, and we create this object called response. Once we do that, the response object has an attribute called text, which contains the HTML source code, and then we're going to pass that into a beautiful soup constructor and then parse it and make this thing called text. So let's go ahead and do this. And once this is done, I also want to point out that if we do response.status code, you should look for 200. If you don't get 200, 301 is a redirect, 403 is forbidden, and 404 is can't find. So if you ever get like that terrible browser, that image on your computer when you're navigating somewhere and it says for like cannot find error 404, that means that the website doesn't exist anymore. 403 means that you generally need to put in some sort of permissions, like some credentials or something. But you want to see this 200. 200 means you're good to go. That's the green light. And then we have this text here I want to show. You can see it's quite large. And if we tried to do text, which, by the way, this is not the same text anymore. Now I'm talking about this beautiful soup object. If we do text.Pretify and we try to print this, it's going to make, it doesn't really make much sense because it's so huge, right? So it might even take quite a long time to do this. But you can see it's very large and it's not very helpful anymore. So let me get rid of this. So we found the pattern in the URLs, and now you can see kind of what I'm getting at. So what we want to do is we want to pass the first URL first. We want to parse it. We want to extract the information we want, and then we want to go to the next. We want to maybe write it to a CSV file, and then we want to go to the next URL, which is where we append start equals to 20 or 40 or 60, right? And so we want to kind of iterate and do this until we've gone to every single page. But how do we find how do we find out the URL of the very last page? Well, we can do one of two things. We can scrape this. We can actually just scrape this number here and then multiply this by 20, and that should be the very last page, I believe. Or what we could do, or I think 142 times 20 should be the very last page, or the number here. So this should be and 142 times 20, and remove the parentheses and actually just evaluate this. That should be the very last page. Or what we can do is look at the total number of reviews, which is located up here, and then we can divide this by 20 and then find out how many pages there are, right? So there are two ways we can kind of do this here. The way we're going to do it here is we're going to use the number of reviews. Yeah, we get a lot of 403s when students are doing projects because everyone's blasting different servers with requests. So here what we're going to do is we're actually going to find the tag that contains this value here. We're going to use regular expression to extract this number and then divide it by 20, and we'll go from there. So now we're actually on the page. Let's figure out how do we locate what this tag or where this value is located, right? So if you're using Chrome or many other browsers, you can right-click anywhere on the page and go down to this inspect here. Okay, so I'll do that again. You right-click, go down to inspect, and that will pull up this this kind of console here, which I'm sure you guys have accidentally opened at one point or another in the past. So now you get to use it. So what we're looking for is this thing here, and if you look, as we kind of scroll over things are getting highlighted. These are the different elements on the page. Now, if you look up here in the corner, we have this little square with a cursor in it. If you click that, and then you can kind of scroll over on the page, you can click an element on the page, and it'll bring you right to that that tag. So it looks like here, this value 2867 reviews is the value of this span tag with class is equal to review count rating qualifier. So what we can do is we can copy this, and we can go back here, and we could say, all right, from our text, we want to find the span tag where the attribute class is equal to review, count, rating, classifier, or qualifier, right? That's what we just extracted. And then, so once we find that tag, which maybe there'll be more than one, but hopefully there's only one, we want to extract the string or the value from that tag, right? So let me comment this out, and we'll look at it. So if we look at number of reviews, which we just made, it looks like we have the actual value. So we've now extracted the value of that tag using this line here, okay? Now, we're not done yet. So what we want to do from here is we want to extract this number, because right now it's a string. We can't do anything. We can't do numerical operations with it. And I also want to point out that something that's very useful is that we can do .strip here, because if we do numberViews.strip, what it will do is it will remove leading and trailing white space. These /n's are considered white space because this is a new line character. This is not the character slash and the character n. This is one character that denotes the new line character. So if we do this .strip, it'll clean it up. Now, we don't really need to do that here because we're going to use regular expressions to extract this number anyway, but this is a very useful thing with web scraping in general because a lot of your text will have kind of these leading and trailing white space. So what we're doing here, I'm not going to get too much into it, but if you're familiar with regular expressions, all they are rules for different patterns that allow us to extract certain strings or substrings from within a string. So for example, we have this number of views here, and we want to extract the number, right? Whatever number from within this string. So what we do is we say, all right, /d, which means digit, and one or more. That's what the plus means. And we want to use this find all function within the regular expression module. And then what are we looking for? We're looking through this number of views, which is this string here. We're going to extract it because this will return a list, and then we're going to convert that string representation of 2867 into an integer. So that's what we're doing here. And so we have 2867. Okay? So I'll go over that one more time. We have this re.findAll. Here's our pattern that we're searching for. Here's the string that we're searching in. And then we're going to extract the first element because it's going to return a list, and it's a list of one, but it's still a list. And then we're going to convert that element into, okay, yeah, I will. So we're going to convert that element into int. So we got to wrap up. So let me just quickly go through here. So now that we have the number, we're going to iterate through this and construct our strings. So now we have our URL list, right, which contains all the different URLs. And if you see here, if you input this, this will actually work for the first page. But now we have a list of a bunch of URLs that will get us to the different pages for the reviews, right? What we do next is we look for the actual review elements here. So if we use our handy dandy square with the cursor on it, we look in here, and we can see that there are all these li tags, right? So we have all these li tags, and it looks like each li tag is a different review. So what we're looking here is we're going to find all the divs with, we're going one level deeper into this li tag, which is this review with sidebar, which is what we have here. So that's all that's going on here, is we're looking within these li tags and extracting this div class. The reason we can't extract the li is because there's nothing that separates this li tag from any other li tag on the page, right? There's no attribute. So if you look at this, there's no attribute within this li tag. So we can't say, hey, I only want the li tags that are reviews. We'll just have to say, give me all the li tags, and we might get some other extraneous li tags that aren't really appropriate. So what we do is we just say, I want the div tags that have class equal to this, and that will give us all of the correct div tags. Now, we're just checking here that we have 20, and that's the 20 on the page. I implore you guys to go through the rest of these. This is how we're going to extract the username, the location, the rating, the date, and the content being the paragraph. But this is all stuff we've seen before, so let's just go over username real quick. So we want to find the A tag with the class equal to user display name JS analytics click. So username is up here. It looks like A tag class username display user display name, JS Analytics, click, and then we want the value from within there, which is why we have .string at the end. Okay. Same thing with location, rating. Here we're using another regular expression to extract the digit from this rating. I would actually just like to show this one because we're actually extracting the attribute value. So here, this is the rating. So what we can do here is look at this rating, and it looks like we have I stars, or it looks like title. The title has the number of stars in our rating, right? So this one is 3. Hopefully this one will say 2. It does say 2. So we can extract the value of the title attribute, or the alt in this case. It looks like if we go in here, this 2.0 star rating. So it looks like we're doing this image thing in the inside here. So we want to extract this 2.0, and then so that's why we're doing the .get alt, because we want the value, just like with the dictionary, we want the value of the alt attribute, which gives us that number. And then we're extracting it again, and so we have this rating. So I'll just run this. We have the name of the first person. We have the location. The rating is 5.0. The date is just another way we're looking through this, and then the content, which is the content of the review itself. Now, I just want to go. This is a lot of text here. What we're doing here is, I'll say here, this is everything we've just done before. So this is what we just did up there. What we're doing here is we're going to open up a CSV file, and we're going to import this CSV module. Okay, so we're going to open up this CSV file. We're going to open up this file connection. We're going to call the file reviews.csv. We're going to put it in write mode, and we're going to have this encoding equal to UTF-8. I also want to mention that if you're on Windows, you might want to put in this new line equal to empty string, because otherwise your CSV file will have a bunch of empty rows between your data. So I actually added that down here as well. Okay, but on Mac it shouldn't be a problem. So we have this CSV file. We create this review writer, which is kind of like a typewriter, and this is like essentially what is going to write our rows to the CSV file. What is a row? Well, a row is going to be one collection of username, location, date, rating, and content. And so you can imagine that each of these values here, these names are going to be the column names. So the column for username will be called username, the column for location will be called location, and so on. The reason we put in a dictionary here, we just literally make a dictionary with all these keys equal to the same column names, and then we can easily write the values to a row using this typewriter object review writer. Okay, so that's all that's going on here. What we're doing here is we're going through each review that we've extracted. So each of these div tags, which contain all the information, and then we're going through each of them. We're iterating through each one, and we're extracting the information for that specific review, saving in a dictionary, and then writing the dictionary values to a row. The very last thing we do is take all that I just said, that for loop, and put it in a function, and then call that function from within the same open file statement. And what we're doing here is we're going to go through each of our URL links in our URL list. So here we have our URL list, which we constructed earlier, with each of those patterns that we were showing before. We're going to get a response object by passing we're going to get the URL. We're going to make a soup object by passing the response, which we've already extracted the text here. And then we're going to find all the reviews, so find all those div tags that contain all this information. And then we're going to scrape everything. And then, so we're going to call this scrape single page. And what this will do is it will go through and iterate through and write all the different rows that we want to write. And the reason we send this review writer is because we need to kind of give this, send this object through so that we can, so it has the instructions on what the file to write to, that kind of thing. And then we sleep for a random amount of time because this kind of helps to confuse the website to make sure that you're not like just you're just spamming requests, which can get you banned from the server. And then if we run this, I need to run this up here first. We can see that we have this print statement that will now print, and we'll start scraping. So we are currently scraping now. We're finished with page 1, finished with page 2 in a few seconds. And I'll just pull up the CSV file to show you what we've done today. So let's go to page 4, and hopefully this stops. doesn't give me a problem. So if I go here, I look at my reviews, which is now in here, and I didn't put the new line, but you can see at least what's going on. If we put new line equals to empty string, it would get rid of these. But we can see we have our data here. We have now scraped Yelp, and we've gotten the review, we've gotten the name, we've gotten the location, the date, and so forth. So now we can go ahead and start doing a data analysis on this data that isn't publicly available in a usable way. I would say it is publicly available, but it's not usable it's not usable, right? And Drace mentioned don't scrape sites like LinkedIn with just sleep. You'll definitely get banned. Even without just sleep, it's very difficult, and it's very hard. I've tried. So there are sites that are very picky about whether or not you can scrape them because, for example, like LinkedIn, where their data online is what they sell. That's their product. If that data is their product, they're going to make it very difficult for you to scrape it. And it's a challenge, but it's very difficult. So this is a very quick introduction to web scraping. I hope you guys enjoyed. I hope you guys learned something. Obviously, in the bootcamp, you'll get a much more in-depth dive into this, and we go into other things like Selenium and Scrapey, which are more kind of more tools you can use for more complicated sites or sites that you can't scrape using Beautiful Soup, which are a lot of them in this new day and age. So again, my name is Alex. I hope thanks for coming. I hope you enjoyed, and stick around for if you want to have any questions answered or anything like that. I'm sure Monisa will be happy to help. And thanks everyone for running this.